Okay, so today we actually get into the calculation piece of the binomial distributions, which is really nice in the calculator, which I have right here. So we'll go ahead and open it up. I'll show you how to use it like I did in the lesson, but I'll do that again so that you can see how we do this first one. So in the first one, I'm always going to define, actually moving forward for all of them, as you can see, I always define my fixed number here and then my probability of success. So that was like up above my step 2 and then my step 4. What is the probability of success here? And what is the number of observations? So here we have that an elk, a baby elk, has a 44% chance of surviving. And in the end, I do look really quick to make sure it says that we're defining the number who survive to adulthood. So I'm going to use that 44%. If it was asking instead for the percent that do not survive, I'd have to do 1 minus this percent, and that would be my success instead. So it's very important to know that. From here, we're going to choose 7 baby elk at random. That's what we're choosing. So 7, that's my N, baby elk. The probability of success of them surviving is 44%. And what we want to know is what is the probability that exactly four survive. Well, that literally becomes a calculator problem for me. So I go here to my calculator that I have connected here. I put that n is 7. The probability of success is 0.44. My x that I care about here, you can actually already see it. It's 4 right there, right? So I could put in 4 here and then go like that for equal for now. And it's this 23%, but you could also look there. So you can see that I have that 23%. Okay, so now for my next one, I'm going to use that same calculator. I'm going to keep it open here because I'll be using it actually kind of the rest of the week here. But for this one, this scenario, we have 10 bare root rhubarb plants, and it says that 5% will die. Okay, 5% will die. And then I look down here to make sure it does say that the number of plants, we're going to measure the number of plants that die. So we're going to use that 5%. Again, be careful. Every once in a while, we'll be using what percent live, and then I'd have to use 90%, or I'm sorry, 95% for the probability of success. But here we're actually measuring this, okay, that they die. They want to know what is the probability that out of the 10, you have exactly one. You have exactly one that dies. Well, I just changed this. 10.05 is my probability. I put 1, exactly 1 dying. That's pretty probable. It's actually more probable that none would die, right? If you have a 5% chance. But here I have a 32-ish percent chance. You'll see I rounded 0.315, 32% chance of exactly 1. Now we get into the ones that are a little bit more complicated. So in this one, it says, so we're going back up to the elk one, but in this one, it says, how surprising would it be for more than 4 elk to survive to adulthood? So in this one, more than 4, more than 4. I have to think about what that means. More than 4 means 5 or more, right? So more than 4 is 5 or 6 or 7. 5 or 6 or 7, because we're going all the way up to 7. So that would be 5 or 6 or 7. That's the part that I want. I want to know what's the probability of 5 or more, 5 or 6 or 7. Well, in order to get 5 or more, I have to take out 4 and below. That's what I have to get rid of. So that's where whenever I'm shading to the right, it's kind of that same idea of the normal distribution in probability. Whenever I'm looking to the right, I have to do 1 minus up to whatever value I want. So if I want 5 and above, I need to get rid of 4 and below. I do 1 minus the probability of x less than or equal to 4. So I have to get that. That's the hardest part, is actually the setup, because now I can just pop over to this again, change it to 7, change my probability back to 0.44. My x now becomes, again, I want it up to 4 this time, 4, right? But this drop down, I don't want it to just take out 4. I would be just taking out 4 here. I want it to take out less than or equal to 4, less than or equal to 4. And we get about an 86% chance, 1 minus my 86% chance, or a 14% chance. 14% chance. Okay. And last one that we're going to do, same type of problem. So this one is, would you be surprised if three or more plants, so again, the hard part is this defining it first, okay, the defining it. So three or more, I want 3, 4, 5, 6, all the way up to 10, right? 3 or more. So I have to get rid of 2 or below. So I take out 1 minus the probability up to 2, greater than or less than or equal to 2. Okay, so I'm going to go back into here. I'm going to change it. This is the one where we have our 10 elephants. The probability, whoops, I'm sorry. This one is 10, 0.05. What was this scenario again? I'll get back to it in a second. And then we have up to 2, and I want to do less than or equal to, the less than or equal to 2. And we have a really good chance, right, of that happening, less than or equal to 2. But I want to know greater than or equal to 2. Well, that's going to be hardly anything. I take 1 minus that 99%. I only have a 1% chance of having 3 or more. 3 or more. That was 3 or more plants die. Plants die. That's right, because there's only a 5% chance that they die. So I really should not have 3 or more. If I had 3 or more, I'd be questioning what Home Depot did to those things to make them die. Okay, and that is all for today. You basically are kind of doing that same thing tomorrow as well, with a little bit more of that greater than or less than. So the video for this one, as far as the lesson, isn't going to be any different.